Greetings, everyone. Here is section 4.3, page 282, number 71. And there are two parts to this question. The first part says, A, if the function f of x equals x cubed plus ax squared plus bx has the local minimum value negative 2/9 root 3 at x equals 1 over the square root of 3, what are the values of a and b? So we'll start with that part first. And so I already found the derivative of the function, as I'm sure you did. It's pretty straightforward. They tell us we have a local minimum value of negative 2/9 root 3 at x equals 1 over root 3. So that means if I plug into the function f 1 divided by the square root of 3, we have to get negative 2/9 times the square root of 3. And so now taking f and plugging in 1 over the square root of 3 in here to f, well, we're going to cube 1 over the square root of 3, and you should be able to at least verify or agree with that that becomes 1 over 3 root 3. And then plus, well, if I square 1 over root 3, I get 1/3, and so this is going to be 1/3 a, and then plus 1 over the square root of 3 times b. Also, since we have the local minimum occurring at 1 over root 3, we know what f prime of 1 over root 3 has to be. Since we're talking about a local extrema here, the local extrema occurs whenever the derivative is 0 or undefined, and since we're dealing with a polynomial in f, the derivative will be it will exist, and therefore the derivative will have to be 0 at this local min. So f prime of 1 over root 3 will have to be equal to 0. And so now we have plugging in into this function here, f prime, we're going to get 1 over root 3 squared is 1/3 times 3 is 1, and then we'll have plus 2 over root 3 times a plus b. And so now what we have here are two equations with two unknowns, and so we just have to solve this system in order to figure out what a and b are. There are a couple different ways we can go about solving this system here. I'm going to use the addition elimination method, and let me do this. Notice that I have a 1/3 a in a... Do I want to do that one? Actually, no. Let's not do that one. I have a 1 over root 3b, and I have a b here. So if I multiply the second equation by negative 1 over root 3, okay, this isn't the best notation, but in my attempt to be efficient here, this is the way I'm going to write this. Normally I wouldn't want brackets on both sides of the equation with this multiplication happening, but again, for efficiency, I'm going to use that poor technique. So when I distribute this negative 1 over root 3, the b's will cancel, and I'll be able to figure out what a is, and then I can go back and find b afterwards. So let me take a look here. So I'm going to have my first equation, negative 2/9 root 3 equals, and we got 1 over 3 root 3. This equation is staying the same. I'm not multiplying it by anything. Plus 1/3 a plus 1 over the square root of 3b. And then the second equation, when I multiply both sides by negative 1 over root 3, I still get 0 here. And then I'm going to end up with a negative 1 over root 3 here. And then the middle term, it was going to be negative 2/3 a minus 2/3 a, and then minus 1 over the square root of 3 times b here. And now if I add these together, we still get negative 2/9 root 3 on the left equals, and for the first two set of terms here that I got to combine, they don't have a common denominator, so let's not get sloppy here and think, as we see some things in common, that we got to go ahead and we can go ahead and subtract them right away. There's a little bit of work. I am going to want to multiply this by 3 on top and 3 on the bottom in order to have the same denominator. And then with that being the case, I'll have 1 minus 3 in the numerator, so that's a negative 2 over 3 root 3 when I combine those together. And then 1/3 minus 2/3 is a negative 1/3 a. And then the b's cancel, of course. And now we just got to solve for a. And I'm just halfway tempted to let you do the rest of this. What I would do is I'd probably fraction bust. I'd probably multiply through by the square root of 3 and by 9. In fact, let's just do it real quick. So I'm multiplying everything by 9 root 3. And so what that does, if I multiply this side by 9 root 3, just write it down. I'm starting to be a little bit lazy because I'm trying to get this done quickly, but let me stop that. The 9's canceled. The root 3 times root 3 would become 3 times negative 2 gives us a negative 6 over here. If I distribute, the root 3's cancel 3, I get another negative 6 over here. And then on the for the other term here, the 3 goes in there 3 times, leaving a negative 3 root 3a. Alright, so now with that, since the negative 6 and negative 6 cancels here like this, I get 0 is equal to this negative 3 root 3a, so that means a has to in fact be 0 for this to happen. And then if a is going to be 0, let's go back over here for one moment and figure out what b is going to have to be. Well, using this second equation right here before we multiply, if a is 0, then I just have 0 is equal to 1 plus b, so that means b has to be equal to negative 1. And there is our solution to the first part of number 71. And so I'm going to go plug these in. If a is 0, then our middle expression here for the derivative is going to be 0, and b was negative 1. So I have f prime is 3x squared minus 1, and that's going to be important for part b. F prime of x is equal to 3x squared minus 1. So now looking at part B says which of the tangent lines to the curve in part A has the smallest slope? Okay, so we're looking for a tangent line from the answer in part A with the smallest slope. So in other words, I want to minimize the slope of the tangent line, or I want to minimize the derivative of that function. I want to minimize f prime. Okay, so that's the goal of this problem. Minimize f prime of x. And so how do we do that? Well, to minimize a function, I take a look at its derivative. Okay, so I need the second derivative. And the second derivative, of course, is going to be 6x. And when is 6x as small as possible? So what we're trying to do here, of course, is I'm sorry, I keep pausing because something doesn't look quite right at the moment. Alright, so no, everything is okay. So now I need to figure out the critical numbers of f prime, so let's set f double prime of x equal to 0, and of course that is when x equals 0. F double prime is never undefined. And so we're using an open interval here, so we have to use our first derivative test for absolute extrema. So we would go from negative infinity to 0, and then 0 to infinity. Just double checking something there. So f double prime of, let's say, negative 1, that's going to be less than 0 because it was negative, or it was 6x, so it would be negative 6. F double prime of positive 1 would be greater than 0. And so the minimum occurs when x equals 0. Let's see. And we say something like this: since f double prime of x is less than 0, for all x less than 0, and f double prime of x is greater than 0 for all x greater than 0 by the second derivative test. I'm sorry, that is not true. By the first derivative test for absolute extrema, f prime has a minimum, let me get a space, at x equals 0. So now, since f prime of x is equal to 3x squared minus 1, f prime of 0 is equal to negative 1, so this gives us the slope of the tangent line at 0, and remember we'll have f of x be equal to x cubed minus x, and so that means f of 0 equals 0, so the equation is y equals negative x at 0, 0, gives us the equation of the tangent line that has the smallest slope. Sorry about the pauses in there a little bit, it's a little distracting sometimes when I'm trying to get this stuff done, but hopefully that was helpful. Go study.